Hi guys, so today we're going to do section 7.4 part 2. Alright, solving equations containing radical expressions. Yesterday we did 7.4 part 1 where we solved radical equations with only one radical. So we isolated that radical and then raised both sides to the inverse of whatever root you were taking. So if it was a square root, you squared both sides. If it was a cube root, you cubed both sides. So today we're going to take a look at when we have an equation with more than one radical. So let's take a look at the first example here. Alright, so when you have two radicals, I would love to just square both sides. However, if you want to square both sides, this isn't working. What would end up happening is you have two different terms here. So if you were to FOIL that, you wouldn't get rid of the radicals. You would end up having a square root again. For example, this squared would be 4 minus x. Your middle term would be this times that. You would have an ugly square root of 4 minus x times x plus 6. And another one of them. And then your last term would have x plus 6 outside of the radical. So you would not be getting rid of a square root. You'd actually be gaining something completely different. So scratch that. So for solving these, step 1, only have one radical on each side. So we are going to move this radical to the right. That way, one of our radicals is isolated. Step 2, square both sides. Put parentheses around the entire left-hand side and the entire right-hand side. The left-hand side, squaring the square root of 4 minus x will release that radical. The right-hand side, we need to FOIL. 2 times 2 is 4. 2 times that radical, and another 2 times that radical is 4 times the square root of x plus 6 plus the square root of x plus 6 squared is just x plus 6. Combining like terms, plus 10 from this 4 and 6 plus 4 times the square root of x plus 6, and we still have 4 minus x on the left hand side. Next step, we need to isolate the remaining radical. We went from having an equation with 2 radicals to now having an equation with 1. So we're going to move our x and our 10 over. In order to get rid of the radical, we need to square both sides. You could get rid of the 4, or we can just square both sides and just remember to square the 4. So, squaring this. Whoop, what just happened here? 36 plus 12, so plus 24 x plus 4x squared equals 4 times 4 is 16. The square root of x plus 6 squared is x plus 6. My 6's look terrible today. Distribute your 16. Move everything to one side. So we have 4x squared. 24 minus 16 is 8x. $36 minus 96 is negative 60. What is nice about this quadratic? We can factor out a 4. Four can't equal 0, so we get rid of them. Factor x plus 5. So x equals -5, x equals 3. What did we learn yesterday about what we have to do with our answers here for radical equations? So let's go back up and look at the original here. We said -5 and 3. We'll write it here so we don't forget. -5 and 3. If we plug in -5, we would have on the left hand side 4 minus -5, so the square root of square root of 9. Does that equal 2 plus the square root of 1? From -5 plus 6, so 3. Does 3 equal 3? That does work out. Not sure where my touch. Let's try out x equals 3. I don't know why my touchscreen decided to. Okay. X equaling 3, the left hand side would be the square root. That's not even the original. Alright, so let's plug in x equals -5 into the original. So 4 minus a -5 is 9. So the square root of 9 minus the square root of 1. 3 minus 1, does that equal 2? Yes. So -5 checks out. Now let's try 3. 4 minus 3 is 1, so the square root of 1 minus the square root of 3 plus 6, which is 9. Does 1 minus 3, does that equal 2? And that answer is no, so 3 is an extraneous root. So your answer for this equation is just -5. Alright, second example here. Let's go through the steps again. So step 1 is isolate one of your radicals. So let's move this radical to the other side. Step 2, square both sides to release your radical. Alright, this is what you will get if you square both sides. Remember, the right hand side you need to FOIL. This middle term here, it is -8 because 4 times a -1 and a 4 times a -1, so there's 2 -4s, so that would be -8. Combine like terms and isolate your radical. So 16 and 3, so 19. Moving to the other side, so that would be negative 24. Well, this is nice. 2n and 2n, when we move that to the other side, they cancel. So you are left with negative 20, negative 8 times the square root of 2n plus 3. Looking at this equation, negative 8 goes into both sides, so we're going to divide both sides by negative 8. So 3 equals the square root of 2n plus 3. Finish this equation and solve for n. Squaring both sides will result in 9 equaling 2n plus 3. 9 minus 3 is 6. Divide both sides by 2, so n equals 3. Take a minute and check to see if 3 is a solution or an extraneous root. On the right hand side, check the work here that you checked to see if n equals 3 is a solution, and it does check out, so n equals 3. So, in conclusion, when solving radical equations that have two radical signs, two radical expressions, step 1, make sure that they are each on opposite sides of the equation. Step 2, square both sides, and you may need to FOIL. Step 3, isolate the remaining radical. If its coefficient does not go into every term on the other side, leave it and make sure you square it like the previous example. Step 4, solve that remaining radical for the variable. Step 5, check for extraneous roots.